Listen up. Create a new project. Today we're not doing a console application. Okay? We are doing something called SFML project. Now, in C++, it does not on its own handle graphics or joystick or mouse or keyboard commands. The reason why it doesn't do that is because every operating system does those things differently than one another. So Windows and Mac don't use the same draw commands as Linux or even Android or iOS. Okay? So we have to use someone else's library. Like, you know how when we go to use square root, we use math.h? We have to find someone else that's made something that does not come with C++. And for us, that library is called SFML. It stands for Simple Fast Multimedia Library. I'll show you the website. But click on that. Okay, and just make a project like you normally would. I think we're on lab 13 or something, right? So hit next, hit finish. You'll have a project here. And you'll notice that it's a lot different than code we've normally been working with. If you hit F9, it should draw something for you. It should draw a green circle on the screen. Okay?
That's crazy.
So there's actually two windows now. You'll have your little console window. Mine's a bit bigger because I have a bigger font. Okay? And then we'll also have this window that we've created that draws stuff in there. So that's going to actually be like where all our graphics go. And then we can still see out, and all our see out stuff will still go there. Okay? So run that, see if you can get that going. Okay, so here's the SFML website, and it can tell you how to code graphics, and there's a lot of like tutorials and stuff like that. It's actually really useful website. We'll get into it later. But you'll notice here that it says it's your application can compile and run out of the box on most common operating systems. That's the most important thing to us. Windows, Linux, Mac, Android, and iOS. So with Windows computers and Linux computers and Mac OS, to make graphics, they usually use a library called OpenGL, or Microsoft has their version called DirectX, and there's a new one called Vulkan. There are these like really crazy graphics libraries where everything's like 3D points in space, and you need to know math, three-dimensional math, and calculus, and all kinds of crazy stuff, vectors. But SFML keeps everything really simple for us. It allows us to draw 2D commands just by calling their simple commands. So it's just a simple library that allows us to access. You know how like the math library allows us to access square root, and we don't really even care how the computer calculates the square root? We just type SQRT. This is kind of the same idea. It's just going to give us basically a layer above our project where we don't need to know how to make all these crazy graphics. We just have to call commands like draw, create circle, set radius of circle and all that. So let's look at our program here. This is kind of like the hello world of graphics programs. If I run it, it's just a green circle. I put comments on all the lines of code so you can get an idea of what each is doing, but basically, there's some new variable types now. There used to just be float, int, right, and string, but now there's a lot more different types, and they're more complicated than just float and int. The first variable we make in our program is called render window, and we give it the name window, and there's a bunch of code here to set its size and set like what the title is, but we're not going to worry about that. Just like when we make a string, if we type the name of the string and hit .length, we can like actually capture how long it is. Window doesn't have that command, but it has tons of commands, and they're all auto-typed. So you can see that we can capture the window into an image, we can clear it, we can close it, we can create another one, we can display it to our monitor, we can draw on it, we can get its position, get its size, we can do all kinds of crazy stuff. We can even like zoom in on the window and zoom out and like get a view of different stuff. The only command we're calling on it today is we are going window.set frame rate limit to 60. Okay, so our window is only going to update itself 60 times a second, which makes sense for these monitors. Okay, here's the first second variable we're making called circle shape. there's a bunch of other ones. There's one called rectangle shape, and there's one called convex shape as well, just to draw basic shapes. Okay, but we'll draw a circle shape first. By default, if I click shape, I can see all the commands there. I can get the color of it, I can get its origin, get points on it, get its radius, get how much it's been rotated. I can move it. The green ones are the things we can do to it. I can set its scale. I can set its outline thickness. I can do all kinds of crazy stuff, which we'll get into later. For now, the only two things I'm doing are setting the radius to 100 pixels here. And I'm also setting its color to green. By default, every color is white if you draw something without giving it a color. And it says here, the default of any circle you draw will always have a radius of 0, so you won't even see it. Okay? Then, this is where all the code for our project, our window, is displaying in this loop. It's a while loop. It's just making sure your window is open and you're not pressing the escape keyboard key. We'll worry about that later, but if I run my program and press escape, it would probably quit it. Watch. It quits my program. So obviously this while loop stopped running because I hit escape. The other thing it checks is if this window is open. Okay? If I close it, it quits my program. If I get rid of this window.isOpen thing, now I won't be able to close my window. Watch. Oh, it did work. Okay, never mind. Oh, that's because I have it here too. Okay, cool. Sorry. Don't worry about that. Don't worry about these events yet either. We want to stay away from these events. Basically, when you have a window that's running 60 times a second, you want to be checking to see if like keyboard presses are taking place, or people are moving your window, or anything like that. Okay? But we're always going to put our code after that event. There's a while loop inside of a while loop. It just checks to see if anything's happening. We're not going to worry about that. We're just basically going to put all our code in here when we go to run our program. Ignore these events for now. Here's what this loop is going to run 60 times a second. Okay? Because I told it to up here. And every 60 times a second, it's going to clear your screen. It's going to erase it. And then it's going to draw something to the video card. That's what window.draw does. And then the last step is it's going to take everything from the video card and display it to the monitor. I don't know if you took grade 10 in Turing. If you just drew everything all at once, like whenever you got the command, you just drew it and made everything flicker really badly. So in Turing, you would set off-screen only. You'd set a command like that, and you would update your monitor just once per frame. So that's what we're doing here too. If I run it, it gives me a green circle on the screen. Okay? Let's try to move it. I'm going to go shape, because that's the name of my circle. I'm going to hit dot and call that move command. There it is. And it's telling me it needs two numbers, an X and a Y. So I'll just say 10 pixels to the X and 0 in the Y. Now I should have this thing moving. Yes. It moves about 600 pixels a second. Why? Because I told it to move 10 pixels and it's running 60 times a second. If I set this to 1, it should move about 60 pixels a second. Okay. Good. Cool. Okay. Bam. Yes? Let's try to get it to bounce. Instead of making this 1, I'll make this a variable. X step. And if I make a variable, I want to not put it in my loop that's running 60 times a second. So I'm going to say float x step equals 1. And that should just be the same program, identical. It's a bit slow for testing purposes, so maybe I'll set it to 5. Okay. Boom. Great. Now I just want to figure out where it is when it hits the side of the monitor. So I am going to see out the position of my shape. Let's see if there's a command called get position. Get position. Aha! So I'll run that. Now I'm going to get an error here. Okay. And the reason I get an error here, and it's a really crazy one, whenever I get really, really long errors, it usually has to do with the cout. Cout right now only works for integers, floats, and strings and characters, okay? This is none of those four. Right now, get position is actually a 2D number. It has an X and a Y. So if I go to the end of it and hit dot, I can see that it has two parts to it. So I actually want to print just the X part, okay? And when I run that, on my monitor here, now I can see the position of this thing. What is it, 580? Now it's 610. I can just hold it by stopping my, oops. Okay, so it looks like when it gets to 600 in its position, ooh, boy, it looks weird when you go full screen, eh? You can go full screen later. I'll show you how to do it. But about 600 is where it hits the edge, okay? So I want to change this value to -5 instead of +5 if this position is ever greater than 600. How do I make the computer make that decision for me? If shape.get position, and it should auto type. Mine's zoomed in so you don't see it, but .x. If that's ever greater than 600, then I want to change this value. I want to basically flip this value. So I could either go x step equals -5, or I could just say x step equals -x step, which says just change its direction. Okay, let's see. Does it work? Yes, it bounces nicely. Okay. Then you can see it goes off the screen the other direction, right? And I could probably stop it and figure out where it is. It's at about 0, because I can see 10, 5, like it's going by 5s, right? I could say else if, oops, dang you, else if shape dot get position. Just gonna let it auto type and hit enter there. Oops. If that's ever less than 0, then I just want to flip x step again. X step equals -x step. There, now it should bounce back off the screen. There you go. Cool, eh? That's graphics basic start there. If I want it really fast, I could go 1000. I don't think we even see it. It just blinks because it goes like, it goes past the 600 and then just comes back to the 1000. You can see it here. It's going from -1000 to 0 to 1000. So that's not a smooth way to do it. But if I pick a number like 500, might be cooler looking. It's still kind of stuck in between 500, 1000. Never gets a chance to really move. So let's try like a random number. 551. Nah, it still gets stuck. Let's try something way less than 600. Maybe half of like 299. See if it looks like it's actually moving. It's still way too fast. Okay. It ends up just kind of setting up like a standing wave pattern for you physics students there.
Mr. B, we do this in my manufacturing class.
What?
Let's code it.
No way.
Yeah.
Like, but G code. G code, right?
Yeah, on the
Yeah.
CNC.
Yeah. Cool. There you go. Okay. So have a look at Lab 13. There's one other thing that I want to discuss quickly. Okay, about how these things draw. So if I go to just like a regular paint program here, first of all, SFML sets up a, right now our window is 800 by 600. This point here is 0, 0. The top corner is not in math like the bottom. And then this corner here is 800 by 600. That's the point 800 by 800 comma 600. Okay. So that's how it's set up. The top left corner is actually the origin of the screen. And then the other issue, the one other issue is that, like, let's say you draw a circle on your screen, right? What SFML does is it binds everything to a box. So when it draws it, it binds it to this little box here. And it sets an origin that it references it from. So if I say, oh, move my circle to point 400, 300, let's say in the middle of the screen, it will actually take the top left corner and move that to the middle of the screen. And that's why your circle actually starts up here, because it's taking the top left corner of this little box and placing it at 0, 0. So sometimes it's advantageous to actually reset the origin, especially on circles, to the center of it. Okay? So there is a question in there that wants you to reset the origin so it's not at the top left. It actually wants you to set it in the center so that when you move the circle, it moves it about its center and not some random kind of anchor point. Okay, so I'll post this video.